what is a dangling pointer? Now, this is also again an operating system concept where we discuss what is a dangling pointer. So, dangling pointer is a pointer that refers to a location in memory that may have been given to someone else by freeing some memory while preserving a pointer to that memory. So, basically, it is a pointer that used to point to a real-time data, but now the data has been cleared. Now the pointer is actually pointing to nothing. Okay, so that is a dangling reference. Now, this is usually a large problem in case of C programming or C++, and this is solved in Rust. So, by contrast, the compiler guarantees that references will never be dangling, because if you have a reference to some data, the compiler will ensure that the data will not go out of scope before the reference of the data does. Okay, so dangling reference is basically a reference which is pointing to nothing. See, let me just create a pointer x which is pointing to the value y in memory, and now I have cleared the value y using a mutable reference. Now what happens? Now x is pointing to nothing, right? So this kind of scenario won't happen in Rust, because Rust would obviously generate or raise a compile time error. But this is possible in case of programming languages like C, where you will be prompted by an error called a segmentation default core dumped. Okay, that is when it happens when you are having some dangling pointers, or you are pointing to a memory that has not been allocated, or you have not allocated memory, and then you're trying to access different variables, etc., etc. So there are different kinds of memory errors that usually happens when you are playing with pointers. Okay, so what is slice? See, a slice of cake or a slice of anything. So it's basically to have a sub part of something old, right? So something old, you can take a sub part. So slices are a reference of a contiguous sequence of elements in a collection rather than the whole of a collection. It is basically a substring or a subarray, something which is sub to our old stuff. Okay, so it's like when you have an array from 1 to 10, a slice would be an array from 2 to 4 or from 2 to 8. So it's actually a sub part of the entire stuff, right? And this is called as a slice. It's like the slice of cake. So you just cut the cake into different slices and you're taking a part out of the entire thing. Okay. Now sometimes we might need to access slices because we only want to take our concentration to that particular point. If you have did some problems like sliding window problems, then we are actually using slices or sliding window to pass from like the entire content of the the data structure. So it's what happens is in Rust, a slice is a kind of reference, so it does not have the ownership. Now, slice type reference is used when we have to return indexes of strings which are cleared without clearing the returned index. And here we would rather return the reference to the slice rather than an index. Now we have a straightforward API that is much harder to mess up. Okay, I'll show you some examples so that it will be more clear for you guys. Yeah, welcome to slices. So this is array, like let mute data is 1, 2, 3, 4. And then I can create a mutable slice of the array that is let slice is and mute data. So what am I doing? I have created an array which is mutable. So this is a mutable array of I32, right? That is integers. So this thing can be changed. Okay, at any point of time, I can change its value. Now, what I'm going to do? I'm going to do is to create a slice, and a slice by means is a subarray. So subarray, now 1 to 4 means containing the elements from index 1 to index 3. So here it would be from 2, 3, 0, 1, 2, 3, 4, right? So it should be from 2 to 4. And the idea is you can also change, like this is can change slice 0 equal to 10, slice 1 equal to 2, and slice 2 equal to 30. Now we are going to print the data by using the debug operator. Okay, now let's see what will happen when we actually try to change the data using this one. So yeah, so if you see that the first creation was 1, 2, 3, 4, 5, right? So the data which is the array, was initially given the values 1, 2, 3, 4, 5. Then I created a reference to that array and named it as a slice. And this is a mutable reference, as you can see. So it can be used to change the values of this subarray. And now I am changing the values of the index 0th value of the slice to 10 and the index 1th value to 20 and the index 2th value to 30. Okay. And now I'm changing the values using the mutable reference. The slice is actually the mutable reference, not an array. It's a reference to the subarray. And now I'm going to try to print this initial array. So when I print that output, you can see the output came out to be 10, 20, 34, 34 and 5. Now why did it change like that? Because I changed the initial value to 10, I changed the second value to 20 and I changed the third method. What will happen if I would try to change slice 3 to 100? And then I try to compile, it still works. And then I do slices. Now you can see that the fourth value has been changed to 100. The fourth value is the index 3 value. Okay. So that is what we did using a slice. I think the idea is clear. Slice is basically a subarray. So slide type is a reference. So we do not, we can return index of strings which are cleared without clearing the return. Here what we do is we create a string, then we keep an ampersand s and we clear it. Now what the problem is, you have an ampersand s, that is you have a reference to the string which has been already now clear. Now the issue with this kind of a program is it would create a dangling pointer that I have mentioned before. So this would end up in an error because you are actually creating and passing a particular kind of ampersand s to the word, and now you are going to clear it. Okay, now what this first word function does is it will give you the index of the first word. Whereas in case of hello world, so this first word function is a it is not a library function. It is something that we have actually created by ourselves. Okay, so if you see in the back, you can see the first word function is actually taking the string and it gives the index to the value. Okay, so we keep the index to the number. What happens here is we will get the index value here, but the issue is we have already cleared the string, so we'll get a integer value to for the value word, but this s has been cleared. So the length is associated with the string. The length associated with the string has been already cleared. So now this will also bring a compile time error asking for resolution. This is not the case in any other language. If you see in C, it does allow you to do all these things and have all these kind of memory errors. Okay. So what happens is the let word will contain the index of the first word. And then we clear the string. Now what happens initially, you see word actually has the size or the index of the first word, right? And we clear the entire string. Now what has it got? Like word has the index of the first like word in the string, but the word has been entirely cleared. Now what is it pointing to? So it does not have a relevant index because we have already cleared the existing string. So this would also be considered as a compile time error in case of Rust. This is really great because Rust can find these kinds of memory errors by default and will obviously show this at compile time, which is really great because we do not have to face this during the execution. The question is, which of the following is a slice equivalent to the entire string in Rust? Here x is the string. So the option A, which is s equal to ampersand x 0 to 2 and s equal to ampersand x, s equal to ampersand x 1, s equal to ampersand x 0 to x dot line. And then you have the second question, which is state whether true or false slice has ownership over the contents it holds. So the first question was, which of the following is a slice equivalent to the entire string in Rust? Here, x is the string. So the answer is option B, that is and ampersand x 2 against everything. Okay. So it's a similar implementation that you can see in the case of Python also. When you can use these double dots or colons, in order to represent the entire string. And the next one is state whether true or false slice has ownership over the content it holds. So the answer is false. As I have mentioned before, does not have ownership. It is actually a reference. Okay. So reference, don't mess it up with ownership. Reference means you are actually only taking the address and not the value. Ownership means you're taking the entire value. Okay.